Assalamualaikum warahmatullahi wabarakatuh. We are from group 2. So today we want to present about our thermodynamic case study. For our group, we choose a hydroelectric power plant as our topic. Our group consists of 3 students. First, Nurul Shahida binti Zulkifli, matric number AN210096. Second, me, Nur Aziani binti Amri, matric number AN210046. And third is Nur Atira Nadia binti Muhammad Faisal, AN210049. So we start from introduction. One of the crucial demands for humanity is access to electricity as a habit on this earth. From the early civilizations, people have been utilizing the power of river currents by spinning water wheels to prepare a grains and fabric. Nowadays, hydroelectric power plant is one of the systems that used to generate the electricity. The largest hydroelectric power plant are in China, Brazil, Canada, the United States, and Russia. The Three Gorges or Sanxia, a hydroelectric facility on China's Yangtze River that is 2.3 kilometers broad and 185 meters high, is the largest hydroelectric facility in the world in terms of installed capacity. Malaysia also used a hydroelectric power plant to supply the electricity to the community. There are a lot of power plants in Malaysia, such as 8 stations of power plants in Pahang, 7 stations in Perak, 3 stations in Sarawak, 1 station in Sabah, and 3 stations in Kelantan and 1 station in Terengganu. Malaysia's largest hydroelectric power plant is located in the state of Sarawak in Malaysian Borneo. The largest hydroelectric facility in the nation with an installed capacity of 2,400 MW is located near Bakun. This system have pros and cons. The pro of this system in hydroelectric power plant are renewable energy source. Due to the fact it generates power using water from the earth, it is regarded as renewable, and hydroelectric is a clean energy source. The cause of this system is environmental damage. Natural water explosion destruction can be significantly affect the environment and the river ecosystem. When there is a food shortage or the start to the breeding season, certain fish species or other wildlife typically migrate. Dam construction may block their migration routes, which could prevent them from the producing or cause fish mortality. So in this case study, we have 3 main objectives. The first one is to analyze how hydroelectric power plant operates. The second objective is to study the calculation and formula that can be relayed. And the third objective to study about the energy process involved in the hydroelectric power plant.
Next is literature review. There are 4 types of hydropower technology to generate electric. First is impoundment. Impoundment is to store river water in a reservoir. Water released from the reservoir flow through a turbine, spinning it and activate a generator to produce electricity. Second is pump storage. Pump storage involves pumping water from a reservoir at a lower elevation to one at a higher elevation in order to store energy in the form of water gravitational potential energy. The stored water is released through turbine during time of high electrical demand to create electricity. Third is run-off river or diversion. Diversion uses little or no water storage. It can control flood, dispatchable electricity, and the provision of fresh water for agriculture. Lastly is tide. A tidal power plant uses the daily rise and fall of ocean level caused by tides be dispatched to provide electricity during time of high demand. For the application, the process of hydroelectric power plant consists 7 components. First, reservoir, located at a higher place since it resides the potential energy of the water. Second, dam, often constructed on a huge river that has excess water and erected at a place where the river's height is sufficient to extract the most energy potential from the water. Third, spillway, enable a controlled release of water flow from the dam into area downstream. Fourth, intake or control gate. It constructed inside the dam to regulate and release water from reservoir. 5. Penstock. It is a long pipe that carries water from the reservoir to the power plant. 6. Turbine. Water from penstock enters the turbine blade, where potential and kinetic energy is changed into rotational energy. Lastly, generators. The generators is rotating shaft creates a magnetic field when the electromagnetic field induction then convert into electricity.
So we go to the calculation and formulation. The mechanical energy of a flowing fluid, which is E mechanical equal to P over rho plus V square over 2 plus GZ, where P over rho is the flow energy, V square over 2 is the kinetic energy, and GZ is the potential energy of the fluid, all per unit mass. So the maximum ideal power generated by turbine, W max equal to mass flow rate times delta E mechanical. So the generator efficiency of generator equal to W electric over W shaft. So the turbine generator efficiency turbine generator equal to efficiency turbine time efficiency generator. So it can be derived to this equation, which is efficiency turbine generator equal to W electric out over delta mechanical fluid, E mechanical fluid. The turbine efficiency of turbine equal to W shaft out over delta E mechanical. And lastly, efficiency of hydroelectric power plant we can calculate by W electric over W max.
Now we proceed to the discussion part. For hydroelectric power plant, we use the Rankine process. The Rankine process is producing meaningful work by turning water into steam, which then expands through a turbine. This thermodynamic cycle changes heat into mechanical energy, which is often convert electrical generation to electricity. So here is the figure of hydroelectric power plant by using the Rankine process. So the step of Rankine process in hydroelectric power plant is consists of 4 components, which is the first one is pump, using a pump to compress the liquid to the high pressure. The second one is boiler, when the compressed liquid is heated to its final temperature, which is boiling. A phase transition from liquid to vapor takes place. The third one is turbine, expansion of the vapor in the turbine. And the last one is condenser, condensation of the vapor in the condenser, where the excess heat is sent into the environment or huge body of water as a final heat sink like a river. Next, the Rankine cycle, in which a working fluid continuously evaporates and condenses, is the basic operational cycle of all power plants. The available temperature range mostly influences the choice of operating fluid. The Rankine cycle operates in the following steps. The first one is isobaric heat transfer. From the heat pump, high pressure liquid enters the boiler and is heated to saturation temperature. The liquid continues to evaporate as more energy is added, eventually becomes saturation steam. So the second step is isobaric heat transfer. In the turbine, the vapor is expanded, creating work that can be turned into electricity. In reality, when the process advances deeper into the two-phase zone, the expansion is constrained by the temperature of the cooling medium and by the erosion of the turbine blade caused by a liquid entrainment in the vapor stream. Vapor quality at the exit should be higher than 90%. The third step is isobaric heat rejection. When the turbine is finished, the vapor-liquid mixture is condensed at the low pressure, often the surface condenser utilizing cooling water. The pressure in the vapor improperly constructed and mentally condenser approach to the saturation pressure of the operating fluid at the cooling water temperature, which is much below than atmospheric pressure. The last step is isentropic compression. In the feed pump, the condensate pressure increase. Since liquid have a low specific volume, pump effort is generally insignificant and frequently disregarded in thermodynamic calculation.
So in conclusion and recommendation, the study has been involved to analyse how a hydroelectric power plant operates, especially in Malaysia. So Malaysia operates a hydroelectric power plant to provide electricity to the locals. Besides, the hydroelectric power plant has more advantages than disadvantages, such as its renewable energy sources that generate power using water from the earth. And furthermore, the calculation and formulation involved in this study, such as the mechanical energy of a flowing fluid, the power generated by turbine, and efficiency of hydroelectric plant has been researched. Lastly, we study about the energy process involved in hydroelectric power plant. For example, the change of energy from potential energy to kinetic energy to mechanical and lastly to electrical energy. So given the possibility of future hydropower expansion in Malaysia, the proposed hydroelectric power project must satisfy acceptable social and environmental criteria. Hydropower needs to meet acceptable social and environmental standards in order to be a renewable and sustainable resource in this country.